Thanks everybody for coming. I wanted to talk today a little bit about 3D printing. Just a little bit of background on why I chose this. I've wanted a 3D printer forever, so I just thought this would be really fun. This is industrial 3D printing. It's a little bit different. Who knows, maybe I'll get something similar, but about industrial additive manufacturing, that's what it's called in industrial settings. The process that we're going to be looking at today is a little bit different than what a lot of people know as the 3D printing, because that uses metal. So it prints different things out of the metal. As you can see right here, so basically you have a fine metal powder that is deposited on an existing surface. A high-powered laser melts that metal to the layer that's below it. So it's basically like a 10-year-old's dream, lasers. 3D printing, you can make whatever you want, but all of the possibilities are awesome. So some of the uses that it's used for in industry, you can make immediate parts for any kind of machinery that you need. You don't have to replace the entire thing. You don't have to wait for parts to ship in. You can basically figure out what you need and print it pretty much immediately. Some issues are, as you can see in this picture, the way that they load it up is they have this fine metal powder that they're pouring into a canister, and that metal powder is then deposited on, like we talked about. And so one of the problems is that there's a potential exposure to respirable particulate matter and nanoparticles. One thing that I talked about in the study is that compared to say like welding, there's a wealth of knowledge about welding and why welding could be so hazardous in the workplace, but there's really nothing yet about additive manufacturing. The goal of this is to measure metal exposures before and after interventions, and to measure the workplace exposures just in general to see exactly what there is. So this is where I start to get a little bit murky. The type of study, they kind of combined two different types of studies. There's cross-sectional and prospective cohort. So they basically went 1 year, they measured particulate and nanoparticle exposure, and they also did some biomonitoring for controls and for the operators of the systems, and also they had welders at this facility. And then in the second year, they went back and they did more sampling for particulate matter and nanoparticles, and they did more biomonitoring, but they didn't include the welders at all. So if that wasn't confusing, I made this little diagram that kind of shows what happens. In year 1, you got all 3 groups. Biomonitoring happens to all 3 groups, but particulate matter and nanoparticle monitoring only happens to those 2 groups. Stationary particulate monitoring only happens to the additive manufacturing, so it didn't happen to the welders at all. Then in between the 2 years, they introduced some interventions at the workplace that were intended to decrease exposure for these workers, specifically working with additive manufacturing with AM. They introduced basically PPE to help protect them, and then when they came back year 2, they were able to figure out if those things were effective. So for monitoring for particulate matter, they did both total dust and inhalable, and for inhalable they used the IOM sampler. They did personal breathing zone for both the welders and the operators, and stationary sampling only at the AM machinery. They didn't do anything with controls, which we'll talk about later. I didn't think that was a great choice. But then they also used immediate sampling, particle counting with Lighthouse, which is the 23 to 10 micrometer range of particles, and they also had nanoparticles. For biomonitoring, they had 2 different types of biomonitoring. They did thermal and urine. So there's thermal, they took Scotch tape and they taped the index finger of the dominant hand 3 times. But the 3rd time that they did that tape, they took it and they analyzed it, and then X-ray fluorescence analyzed it. And they also did it once randomly on some surface throughout the facility nearby the AM machine. And then they also did urine. They collected it at the beginning and the end of the work week to kind of see if it increased throughout the work week before the weekend. And then except for some reason they didn't do the controls year one, they didn't do the end of they only did the beginning of the work week. And there you can see kind of the gender and age distribution of who they had. For the AM operators who were interested in, they had about 7 the first year and then 11 the second year. Which they did say was everybody that they had at this facility. So keep that in mind. That's like, you know, statistically something that are a little bit murky, but that's because they just didn't have very many people. Oops. So some of the results, here's our particular matters. Oh, this does have those later. This is what the results were by, we got inhalable right here and total dust right here. And then years 1 and 2, and then 1 was only done, the total dust was only done year 1. But you can see some interesting things of note. This first one, almost all of the levels were statistically below, we can be statistically confident that they're below the occupational exposure limits for Sweden, except for this one. In the second year, for the additive manufacturing for cobalt. That was the only one that statistically they said possibly could have been above the occupational limit. So that's good. Not too many people were over. Then we also we showed higher levels of cobalt for additive workers and welders. So you can see that there. That clearly the additive manufacturing was higher than the welding. And same thing with nickel. Higher nickel levels in the air than the welders. So that's interesting because welding we know is so, you know, hazardous in certain ways, but additive manufacturing was showing higher levels than welding. Additionally, let me see here. Oh yeah. So we can see here the only ones to decrease after the interventions were set in the first and second year for the additive manufacturer operators was for iron. It went from 134 to 50 micrograms per cubic meter. But again, statistically, it isn't completely valid. We're not completely confident on that. Here's some of the nanoparticle monitoring results from the Lighthouse. I believe no, the nanoparticle measure. I can't remember, but you can see the big thing to note here is that all of these blue lines, that was all welding when they monitored with welding, and then these smaller lines down here are from additive manufacturing. So we know with a little bit of certainty that it's not as severe as welding, it's the nanoparticles. With urine biomonitoring, we have the results here. We can see that for year 1, 43% of the additive manufacturing levels were high for cobalt, nickel, and chromium, which makes sense because those were some of the most common metals within the powder that they were using. But in the second, oh, that was for dirt. Sorry, I'm getting them too mixed up. So, for urine, you can see the results there that, sorry, I gotta read this. So it looks like what happened was the additive manufacturing was higher than the controls, but we don't know that statistically. The second year it was less than for cobalt and nickel, but the chromium was still high. And then like we talked about with the thermal biomonitoring, 43% returned detectable amounts for year 1, but then year 2, when they came back into it again, there was no evidence of any exposure on the data. Which makes sense because in that second one, it says the reason for the reduced levels of thermal exposure between year 1 and year 2 probably depends on stricter safety instructions and increased use of flux. That would make sense. One of the big things that they introduced between year 1 and year 2 was the PPE that was meant specifically to reduce that thermal exposure. The problem is that well, this was also interesting. The participants with the highest levels of cobalt on their hands were the same individuals who had the highest level of cobalt in the urine. So we know that there's probably a link between the dermal exposure and their urine levels. So some things that are important from those results, the most of the occupational levels of dust were below occupational code limits according to Swedish standards. That's good, and we can at least establish that based on, because we don't have much background for additive manufacturing, so it's helpful to know that those things aren't that much of a concern. The air filter showed higher cobalt exposures for additive manufacturing workers and welders. So cobalt, like it says, cobalt is one of the main ingredients on the dust that they use in additive manufacturing, so that would make sense. But overall, it was lower than welding, which is also good to know. Nanoparticle exposure was not as relevant for them than welders, and dermal bioanalysis showed lower levels after workplace interventions. But this is what I thought the most important part was, is that airborne and urine metals remain the same. So I guess airborne makes sense because the interventions that they introduced were only PPE. There was no like actual engineering or elimination interventions that they made. But the problem was that even though dermal went down, the urine levels stayed the same. So we know that likely these workers are still receiving the same dose, even if they're wearing this PPE. So an interesting thing to note. So some strengths that I thought of for this this study. Most importantly, I felt like it was a good start. Like they talked about, there isn't a lot of background to this. It's kind of a new technology. Multiple forms of analysis. It kind of really painted a broad picture of what is exactly happening in the workplace right now, which I thought was super helpful. It was really nice that they had a clear pre-intervention and post-intervention. They had year one, and then they had the intervention, and then they had about 6 months before the next intervention. Weaknesses, like we kind of talked about, very low number of participants. Like you guys saw on the results section, there's a high range, or there was a large area of confidence. So it's hard to statistically say much based on these results that we have here. The welders weren't sampled in year 2, which I thought would have been helpful to kind of see kind of the changes in that compared to the additive manufacturing. You know, maybe they added some kind of ventilation, maybe they didn't, or maybe something stopped working. It would have been really helpful to know if the welders, if their trends were the same as the additive manufacturing. The particulate monitoring, the immediate results show like high peaks. And so even though we know everything below the occupational exposure limit, we don't know exactly, like, you know, there might be peaks that could be concerning, that could be of concern for health, that would validate more research into it. At an unclear purpose, I felt like the two different, like they were comparing the additive manufacturer operators to the welders in year 1, and like, so that was almost like a purpose and the goal in and of itself, that we're going to see like how it compares to welding and also to the controls. But then they came back second year, and so they kind of put that in the paper too, to like compare interventions, and they also like did year 2 compared to the controls but not the welding, like we kind of talked about. It's kind of unclear. Personally, I think I would have, you know, split it up a little bit more. Yeah, so first question, some questions I thought of, you know, would you have separated these results into 2 papers? Like, I'm interested to see what you guys' thoughts are and why or why not. And yeah, they also said that they recruited all available additive manufacturer operators at the site. I don't know, like, how would you increase the statistical power? Could you, like, they said that this was probably one of the premier additive manufacturing sites in Europe. This was in Swedish words actually, but this was in the country and in the continent. So that was kind of interesting, just the idea of how you could get some more people. How would you follow up on this research to further analyze health risks to these people? I think that's obviously the next step. We need more research, trying to get more statistical power. And what would you guys do different in this study? So yeah, any questions or thoughts?
Can everyone chime in at once? Matt, I mean, you asked these questions, and so I guess, what do you think about some of these things?
Yeah, I to be able to answer the questions I asked for sure. Like I said, I would probably split this into two papers. If I just felt a little jumbled between the two. I felt like, as far as the second question for statistical power and recruiting more people, I felt like it would have been useful to try and recruit another site or some more people from another location that would introduce some variability in their interventions, and also like ventilation, things like that, that would really give a broader picture of exactly what exposures are looking like. Because right now it's kind of hard to apply this to the entire additive manufacturing industry, right? Because we only know about this one place that has these specific interventions and these specific machines. So personally, I think I would have tried to find more people to introduce to my study, maybe partner with somebody else. But of course, that's easier said than done. And what else would I do different? Yeah, really, it's just those two big things, trying to clarify some things between what the purpose of the paper was and finding more people. Any other thoughts? Yeah.
So just from the brief reading, it seems like they kind of turned up for a week in one year, and then they turned up for a week in the subsequent year, right?
Mm-hmm.
And each worker was an observation for that week. I don't have any experience with the like actual physical monitoring equipment, but it seems like some of these like sampling devices you could leave on an ongoing basis. And so you could increase your statistical power not by adding additional subjects, but adding additional observations of the same subjects.
Yeah.
For longer periods of time, which again.
Yeah, absolutely. I think that's a great point that I didn't think of. And additionally, then that would allow you to introduce different settings as well, because you never know, like the ventilation in the warehouse is going to be different in the summer than in the winter. So maybe that would be a great idea to go back another time with the same intervention. Yeah, Dan.
I have a friend who his job is a welder, not additive manufacturing, but he's a welder professionally. So obviously he'll be exposed on the job possibly to heavy metals that they use, but he also does it a lot in his free time. This is a hobby. He likes to make stuff and build stuff and work on his car. And so I'd also maybe like to, forgive me if it is in the paper, but I would maybe like to see them ask about whether they do this off the job. And then I don't know if that could confound the urine results or the derm results of the heavy metals that they tested for.
Yeah, you mean like additive manufacturing out of the job or welding off of the job?
I guess both.
Yeah. I know that they did talk to one of the guys who said that he had methamphetamine a little bit more than normal and he wasn't wearing PPE. So that was one compounder that they addressed at the end. So that's a good point, something to bring up. Something else to bring up that I forgot to bring up about the results that is kind of interesting. Cobalt. Let's see, no. One of these went way up in year 2. I think it's no. I can't remember which one it was, but there was one where like they were drinking coffee with metal in it, and so their results just skyrocketed. So that kind of rendered some of the results invalid. So kind of interesting. Any other thoughts? Any other questions for me?
What do you think about the way they measured the dermal exposure? I think we might have talked about this a little bit in your Flash Journal Club. But like the tape, do you think that the methodology there was sufficient, or that, you know, you think of having anything, or like what could I be touching that may influence the results? I don't know.
Yeah, I think, yeah, we did talk about that, and I did do some more research into it. And it does seem like it's at first when I read about that, it kind of seemed very rudimentary and not very valid, but as I did read into it, it does seem like it is something that people have used in the past, like they cited a few papers, I think, that talk about using Scotch tape or the specific method to measure thermal exposures. And so I think it's good, but yeah, there is an issue of what if they're touching something with their hands that like is more than just what they're being exposed to, especially with it being the right finger of their dominant hand or their index finger of their dominant hand. You're always touching things, and if we're just trying to get exposure of, you know, additive manufacturing, that might introduce other exposures from other things around the warehouse that you might be touching. So, yeah, I think, yeah, did that answer your question? I think it is semi-valid from what I felt, or from what I researched.
Could you go back to the particle monitoring table?
Yeah.
Yeah, it's all sideways in the document. Okay, yeah, so what hypotheses are they actually reporting significance for here?
Yeah,
Because it's kind of all over the place. And do you think those were the right hypotheses to be tested?
yeah, I mean, that's kind of, you know, talking back into that question, like, what are we even looking for with like both the 2-year analysis and also comparing it to welders? From what I understood, I think they were just trying to compare it to each other between welders and the controls and the additive manufacturing. So that's a great question. I think that would probably be my best guess. All of these 90%, 95% confident intervals are like, you know, super wide. And I think when they reported stuff in the paper that says, hey, we know statistically that this was below the welders, there was only like one actual thing that they know statistically that they were different. So yeah, I think that was their hypothesis was, is it higher or lower than the welders and by how much?
Which I think maybe the more interesting question, and probably why they didn't ask it, they didn't get any significance, but are these different from the occupational exposure limits? Like, I think that's probably the more relevant question, right?
Yeah. And yeah, which they only had one, I think, that they mentioned like could have possibly been above the occupational exposure limits, but yeah, they didn't have great confidence levels. So.
Anyone online? Anything, any questions, comments? All right, anything else for Matt? Right.
So there, I'm gonna go grab.
Can you hear me okay? Is this quiet? Okay. Sweet. All right. Thanks for going before me, Matt, and dressing a lot nicer than I am. I enjoyed your presentation a lot. So mine is about hearing conservation programs and how effective they are and what components of hearing conservation programs are most effective. And just some background for why I might have picked this topic is because one of my industrial hygiene work internships, I basically spent 3 months running like a noise exposure measurement program, and I took dozens and dozens of dosimetry samples and did lots of stuff with hearing conservation programs. So it's like kind of interesting to me, even though it might not be to the regular person. So So this study is titled Assessing Hearing Conservation Program Effectiveness, Results of a Multi-Site Assessment. So for background, they of course have to talk about noise-induced hearing loss, which, as many of you know, is one of the most prevalent occupational conditions that still goes on. It happens in many, many industries: manufacturing, agriculture, construction, in the military. They're all it's very prevalent. And it's caused by people being exposed to noise that is over 85 decibels for over 8 hours. That's when they're considered to kind of receive like a 100% dose. So like in the 1980s, OSHA made an amendment to the hearing conservation laws, requiring workplaces to actually have an HCP, hearing conservation program, in place if they are experiencing exposures over 85 decibels over an 8-hour TWA. So that law has ushered in lots and lots of hearing conservation programs to be put in place at lots of companies. However, noise-induced hearing loss hasn't really significantly gone down. And so they kind of say, despite the existence of such programs, such hearing conservation programs, noise-induced hearing loss remains one of the most prevalent occupational conditions. And in fact, in other developing countries, it constitutes an even greater burden of adult hearing loss. So they said some of the reasons for this may be because in less formal work settings, such as construction, hearing conservation programs may just not even exist. Construction settings are usually somewhat transient. They switch sites and the workers are all, they're not in an office, and it can be hard to implement a hearing conservation program. Additionally, hearing conservation programs in places that do have them may not even be effectively implemented. And the issue with this is that currently as according to the study, it said currently there's really no way to tell if a hearing conservation program is good or if it sucks. And so they said there's a few ways workplaces might try to assess it, even if there's not a universal way to do it, such as NIOSH has developed an audit checklist for your hearing conservation program. You could consult that. Sometimes companies will just look at the OSHA requirements and say, okay, are we checking all these boxes? If so, we must have a good hearing conservation program. Other companies might put resources into lagging indicators, such as they'll test their workers annually to see if their hearing thresholds have shifted, whether or not they're experiencing hearing loss. Now, obviously, that's an issue since it's a lagging indicator, meaning once you learn about the issue, you've already failed to prevent it. So the objective of this study is of this paper specifically, is to investigate the relative value of different components of an HCP in preventing hearing loss by gathering and comparing data from a multi-variable, multi-site analysis, and they get lots of data. So they're doing two main things, one of which is visiting sites where they will conduct interviews with managers and with employees. They'll also do focus groups and do observations and walkthroughs. And additionally, they're going to compare all of that qualitative data with quantitative data, which is audiometric data, lagging indicators that I talked about. So something that's interesting is they're taking an approach that's not like a checklist. It's not, just lagging indicators. They're trying to assess what components of an HCP is most effective through a very in-depth multi-method analysis. So I think that was really cool. The selection methods for their study population takes place at multiple plants located all across America under one metal manufacturing company. So this company owns about 40 plants. However, only plants which have a hearing conservation program and have a database of the last 5 years of audiometric data, hearing threshold data, those are the only ones that were eligible to be included in the study. So they reached out to them, and 14 of them said, yeah, we're down, and agreed to participate in the study. Out of the 14, one was excluded for having insufficient data in the audiometric data. So that, oops, I made a typo. A total of 13 plants were included in the study. So, like I said, their quantitative method for collecting this data was just by looking at audiometric records from testing hearing thresholds. So this was gathered from all the plants for all the workers that were involved in an HCP for the last 5 years. They also conducted site visits between 2012 and 2015. And during these visits, which lasted from 2 to 3 days, I believe, they did walkthroughs of the work site. They took dosimetry, like samples of noise, both on workers and in areas. And they administered the standardized questionnaire to managers and medical staff, kind of the people in charge of the HCPs. They also gave written surveys to workers during their breaks and lunch times, which usually they said should have taken only about a minute to finish. And lastly, they also grabbed worker focus groups and did like group interviews about their perceived culture of the hearing conservation program and how they feel management is handling noise-induced hearing loss. And so they, as you can see, they did quite a bunch of things, quite a few things to gather as much information as they could. Now, with how they analyzed all this information, I'll just read you what they said. So they said because like of the inherently nested nature of these groups, since they're in different plants, they used a multi-level regression model. They used it to assess the independent associations between hearing loss and both the worker and facility characteristics. This strategy separates within facility variation from between facility variation and models the assumption that underlying differences in the quality of the HCP leads to systemic differences among facility hearing loss rates. So I really like how they did this because they recognized there could be lots of systemic bias just by the fact that the different plants are participating in this. And so I like how they accounted for that. So in this model, the outcome they were looking at was individuals' annual rate of change in the binaural average of hearing thresholds for 3, 4, and 6 kilohertz KHZ over the previous 10-year period. And in this model, they assessed that outcome against the employee demographics that they measured, manager survey factors that they identified and measured through those surveys, as well as the employee survey factors. So they tabulated in table 4, which I don't know why this wasn't the first table. The first few tables are mostly showing kind of the parameters of study, like how many participants there were. But table 4 has all of the variables that achieve statistical significance, which in this study was a p-value of 0.1. And in table 4, we can see all the variables that are significant, employee variables, such as like their demographics, the survey variables from managers, and the survey variables from employees. So this table is huge, so I split it into 3 parts. So we're gonna look at table 4 for like the next 3 slides. So in employee variables, they noticed that age, sex, race were all significant indicators of how much hearing loss would happen at a plant and for an individual worker. And something else that was interesting was also like base tinnitus rates and levels and baseline hearing was also significant, which makes sense. So for the employee survey responses, they got, out of all the few questions they asked, 2 of them registered as significant variables that affected the outcome, which was levels of hearing loss. And these were questions that they asked the employees, such as, when you had your most recent hearing test, did anyone talk to you about your hearing? So if they were like counseled about the dangers of noise-induced hearing loss, or if they just had some one-on-one counseling or interaction about it, that seemed to have a significant impact on reducing the amount of hearing loss experienced. Additionally, they found through employees that workplace level of commitment to hearing loss prevention, if it was high, that also contributed to a decreased level of hearing loss. And so these were the variables they found from the employee survey. And when they surveyed the managers, it was kind of interesting. Something they found was that the responses from the managers were extremely similar to each other across all the plants. And they also did generate some significant findings. So manager survey items that remained in the fully adjusted final model included the timing of annual audiograms, whether noise sampling included personal sampling versus personal and area sampling, and whether or not workers complained about hearing protection devices interfering with work. Plants that conducted annual audiometric testing during or after work shifts compared to before work shifts showed higher rates of hearing loss, and plants which noise monitoring efforts included both personal and area sampling showed lower rates of hearing loss. And finally, plants in which managers had received, let's see, how do I scroll? Okay, well, anyways, so they definitely found a lot more interesting variables that seem to contribute to effective HCP components. So they also found some other salient themes through their focus groups, some of which are really interesting. So something that they found was that the perceived level of management commitment to hearing conservation usually helped. And well, let's see. So they conducted 126 focus groups, each of which had from 6 to 14 people, for a total of like almost 800 participants. So they perceived that the management was pretty committed to hearing conservation. They said, yeah, there's quite a variety of hearing protection devices. They were available and they were accessible. Something also that I found pretty kind of funny actually was that employees seemed to perceive that there was a generally high management commitment to hearing conservation programs, but and high levels of personal commitment to protecting hearing on the job. In contrast, of course, in less than half the study sites did focus groups participants report a strong personal investment in protecting hearing off the job. So it's just interesting to see how someone mentioned that at work and at home exposures might all contribute to the same problem. And it's interesting to see how their attitudes might have differentiated. So they mentioned some of the strengths and weaknesses of their study, and I kind of agree and am inclined to agree with most of them. One of the strengths they mentioned is that the number of facilities assessed and the in-depth nature and mixed methods approach to the data collection at each location kind of gives like a good, strong study. And I agree with that because they had a lot of participants. I can't recall the exact number off the top of my head, but over the 13 plants that they sampled, there were quite a few points of data. And also, the fact that they used mixed methods, they didn't only interview the managers, or they didn't only interview employees, or they didn't only look at audiometric testing to determine which HCPs were working, which ones weren't. I think that was a very good idea. And I think that's also a good standard for what they're looking for, since they're kind of, in a way, trying to prove that this might be a good way to approach assessing these programs at work rather than the old method of just doing a checklist. They said some of the weaknesses of this are that it is a retrospective study in regards to some of the outcome data, that being like the threshold shifts in hearing. And also the fact that all the study locations were part of one like company that has a company-wide HCP policy, that definitely could have given a bit of like a systemic bias. And so that actually kind of was reflected. They talked about in their discussion with the fact that when they administered the questionnaire to the managers of these plants, that their responses were quite similar all across the board. And they said that even though these responses seem to all be similar, like the managers are saying, yeah, we all do this the same way. We all believe it. This is important about the same amount. There was still quite a bit of variability when it came to the actual outcome of hearing loss amongst the plants. And they discussed kind of some of the reasons why, even though all the managers seem to be on board and like saying similar things, why the outcomes might be different. They said that even though all plants are part of a corporate leadership, these HCPs are administered locally. And so judging by the fact that a safety culture might be drastically different from one plant to another, or manager styles or communication, or even the amount of money they're spending, all of that can contribute to variance and difference in outcomes. Additionally, the researchers suspected that some response bias may have occurred when the managers were interviewed. Since managers are higher level employees of the company, they might have been more inclined to identify the correct answer that they should give, to reflect the company's policy. And that's what they said in the interview survey. Additionally, one last thing that they identified might have accounted for this lack of variability is systemic bias due to the fact that high-level administrators in general might just be unfamiliar with hearing conservation programs and exactly how they're implemented in the trenches, what things are going on, what hearing protection devices are being used at the actual workers on the machines, since they're higher level. And they also might not be as aware of the effects. Perhaps they're too busy looking at their revenue charts or how much money they lost in the last quarter. But either way, these are some really interesting observations, and that kind of leads to an interesting conclusion. They said that the overall message from their results is just how important it is for worker input to be part of a workplace program evaluation, as well as, and then they identified a few specific parts of an HCP that seemed really effective, which included worker counseling and management commitment to occupational health and prevention. And lastly, they kind of patted themselves on the back and said, yeah, and we think our method is pretty valid. A combination of qualitative and quantitative assessments, such as we performed, is likely to contribute to the assessment of program quality and effectiveness. And so I don't have a slide specifically for questions, but kind of the one that I wanted to pose is, how do you think this is a good assessment tool? Do you think the way they did it is like a reasonable thing that all companies might be interested in adopting? Or what flaws do you see in it, if not? And that's kind of the main takeaway for me. So questions or thoughts?
This last summer, similar to you doing an internship doing hearing conservation, I did it for a metal manufacturing plant that has probably about 40 plants throughout the US. So not saying anything here, but I know for a fact that, yeah, you kind of hit it on the head. A lot of those managers, they know what the right answer is. But the managers that I worked with, there was a wide variety of they were gonna keep our workers from going deaf to hey, I don't care, just get your stuff done. And so I think if I were to redo this, evaluation for hearing conservation, having been the one trying to get it implemented in a lot of these sites, I would definitely be asking more from the people, like the boots on the ground, what their perception of the program is as compared to the managers.
Yeah, no, I agree. I think that was probably their best like finding from the study is the fact that like, hey, when you assess HCPs, like if you gotta pick like who to interview, go into the trenches and ask the workers, so. Daniel?
Yeah, I definitely agree with that, like, you know, obviously workers they don't always obey the rules and they're gonna, you know, take off their hearing protection to talk to somebody or, you know, whatever it might be for whatever reason during their work shift. And obviously, if no one's watching them, there's no enforcement. So it's hard to say how effective a conservation program is if people still, you know, kind of stray away from the guidelines that they're supposed to be following, and especially if managers are kind of passive toward it as well. And then another thing that I would like to see, I think you might have mentioned this briefly, but I also couldn't really find anything about it in the paper. It would be some type of assessment on noise exposure outside of work, again, with the outside of work stuff, but especially with, you know, people blasting music in their cars on, you know, during their commute or on their spare time, listening to music with headphones or AirPods. I think that could contribute even more to hearing loss, if they don't have any time to like recover after their shift. So I think that would also be a tool to include in an assessment as well, but you don't want to invade their privacy either, so.
Yeah. I think something I forgot to mention that you reminded me of. I think one of my main problems with this study is technically like the hypothesis that they're testing is what perceived or actual parts of a hearing conservation program are most effective at reducing hearing loss. But they also kind of try to tackle the question of like, also, is our method of assessing this valid? And I think they answered the first question really well, that, you know, employee engagement and worker input and management commitment is really important for hearing conservation programs. But I think if they wanted to make the second claim that our combination of qualitative and quantitative assessment tools is probably a good tool to assess these hearing conservation programs, I think that claim is not as well backed up, and that they should have, if they really wanted to talk more on that, they should have done maybe a separate study or included in the study some controls such as let's also like have a manager do a typical NIOSH checklist, audit checklist, and see how that checklist is determining the strength of your HCP and compare it to what we think how good your HCP is based off of our tools. And so I think that is one of the issues that I had with the study. Yeah.
I'm gonna complain about stats more. So, they used a cool model. This multi-level stuff is interesting and it's really well suited to the type of data they used. Great choice. Problem is, whenever you're using these kind of fancier models, there's a lot of knobs you can turn. And one of the knobs you can turn on the type of model that they used is that it can model different distributions of data, stuff that's skewed, counts, normally distributed, whole bunch of different stuff. And they never tell you which kind of option they picked. So at least within the context of like the information in the paper, there's no way to actually interpret the regression coefficients they give you because you don't know what they're actually like modeling. So I know it's kind of esoteric, but the point is if you find yourself kind of picking a fancier and fancier model, make sure you give your reader all the information they need to know what you did so that they can actually interpret the numbers you're giving them. And that was kind of one weakness of this one.
Yeah, no, that's true. Definitely, it can cast into doubt like your findings if you didn't really, you can't really replicate them. You can't know exactly, oh, I put this into SAS and it didn't really spit out the same numbers as you did. So like, you want to share your code or something like?
Like I've got a pretty good guess at what they did, but they never tell me. And like, if you don't know who's gonna have your paper in their hands, right? And like how knowledgeable they're gonna be about this stuff.
Yeah. No, I agree. Thanks for pointing that out too, because biostats definitely is not my strongest suit, but that is important to know. Cool. Any other thoughts or questions?
James, if you were working at a manufacturing plant or whatever, and you were in charge of designing the heron conservation program, is this an article that you find a value in, that you'd be trying to base some decisions about how you would design that program off of? And if so, what did you learn from the article that would, you think, inform how you would devise that program?
That's a great question. I actually do think I would, if I had to design an HCP program for my workplace, I'd probably obviously fulfill like the requirements, but use this kind of method to assess it. Audiometric testing is usually the gold standard as it is now, to be like, oh, we're doing a good job or we're doing a bad job. But I think the quantitative aspect that they included that most workplaces don't do, I think that's really valuable too. Because then you know what was working the best and what isn't. Now, obviously, this would only work if I was working for a company that had multiple locations where HCPs could differ. But yeah. So given that scale of work, I think not only audiometric data, but quantitative or qualitative data would be really useful in assessing and adjusting my HCPs to be better and more protective. So I do like what they did.